Hi everyone, welcome to UChicago ICPC. Today we will walk through a 2025 Asian Pacific problem. Problem D, the Tower of Hanoi. Consider this example. We have 3 pegs. The first peg has a disk of radius 3, and the third peg has 3 disks of radius 1, 2, 4. 1, 2, and 4. And the goal is to find how many steps to move all of the disks onto rod 1. There will be queries and also updates. Therefore, the idea is to use a segment tree. There will be n disks, and the total time complexity will be q times log n. So how to build the segment tree? Let's draw it out. This is a root node. Each of the leaf node will represent disk 1, disk 2, disk 3, and disk 4. Disk 1 is at which peg? It's at peg 3. For node 2, it's also on peg 3. So this is leaf 3. Disk 3 is on peg 1. So let's say peg 1. For disk 4, it's on leaf 3 as well. What will each of the leaves contain? This will contain an array of steps, which stores if we want to move the disk 1 to all of the rod position, how many steps will it take? And also keep a auxiliary array. In this example, move disk 1 to rod 1. Because disk 1 is at position 3 and moving it to rod 1, we will need the auxiliary rod of 2. So let's fill in 2 here. And how many steps to move from peg 3 to 1? It's just 1 step. And to move to position 2, the auxiliary will be 1, and the steps will also be 1. To move to position 3, we don't need any steps. So the steps 0, and the auxiliary node is also 3. Now, how to find the internal node? So this block of 1 and 2. What does that mean? It means moving this block of 1 and 2 to all the desired locations. How many steps we need? So let's write the function here. For example, block of 1 and 2 will equal to building the block of using block 1 and block 2. To make it general, to call it block A and block B. Let's draw an example here. Here is block A, and the block B will be on the bottom, which is a bigger block. So now, the block A and B will just be merging those 2 blocks, A and B. How to conduct the merge for T in 1, 2, 3. So rod 1, rod 2, and rod 3. If the target rod is those 3 blocks, we will first get the auxiliary rod equal to block B's auxiliary rod for this target rod. Let's say T is rod 1. If we want to move AB all to rod 1, what's the auxiliary rod? Isn't it just 2, which is the auxiliary rod of the bottom one? And for the steps will equal to, for the target of T, the top block's steps will move top block to the auxiliary position, and then plus moving the bottom block B to the target position. And then what's the last part? So once we moved A here and B here, and then the last part may move A on top of B, which is moving to the target position. So move bottom to target. So for the middle part of moving the bottom block B to the target, and then it does block B dot steps to the target position plus the final block of moving A dot steps to the target. So the steps will become this of the three parts. And what is the auxiliary of the for T? The auxiliary will be A dot aux, because moving those two to the target, we will first need to move A to an auxiliary position. So the auxiliary rod needed is exactly what the top block's auxiliary position. In this way, we can calculate all the middle blocks, block 1, 2, and then block 3 and 4, right? By merging those two children. And finally, we will get block of 1, 2, 3, 4. With this tree built, we can get any segments, say a block of 1, 2, 3, 4, moving to the target rod of 1, and get this query in log n time. And also updating a leaf node, such as shifting this to another location, we will just traverse half of the tree, which will also be log n. And that is how we achieve the log n for each query. Thank you for watching.